So transformation of shapes, right, on a graph. The four that you're expected to know are reflections, translations, rotations, and enlargements. All right, so those are the main types, right, for any shapes and things that you're given. What we're actually going to do is start with translations, because that's the simplest one. All right, so what does a translation mean? Let me go with, doesn't matter, translations. Translation simply means moving. Moving a shape or indeed a point, all right? But usually in your GCSE, you're going to get a shape that you have to move one way or another, okay? Now, in order to know how we're going to move something, in what direction and how far, all right, we use a column vector. I'll explain what that means. Excuse me. And it's in the form XY like that. It's always given in a column, not across, but up and down, right? And what these two numbers, so for example, you could have 3, 2, like that, all right? The top one always refers to the x-axis. So that means horizontal, all right? So this one, horizontal. The second one, the bottom one, is always y, referring to the y-axis. So that is the vertical movement. All right. So if we take just one or two examples, the 3, 2, 1 that I was just talking about, that one means 3 to the right and 2 up. All right. Right and up are in the positive XY axes. So if you have that, yeah, remember that this is plus on the x-axis, positive numbers, and similarly up is positive on the y-axis, and left is minus on the x-axis, and down is minus on the y-axis. Okay, so if these numbers are positive, like the ones we have here, then they're going to be in the positive directions. Okay, so if we had, for example, -2, all right, and -1, that one there, any idea what's that going to look like? Which direction do you move it in?
It's to the left and 1 down.
Excellent. Oops. You know what? I keep pressing the erase button. 2 left, 1 down. It literally is as simple as that. Okay? So if you had, if I did a, I don't know, quick example. Okay? So imagine you had a triangle like that, just rough and ready, all right? And you wanted to move it by -3 and -4 even, like that, all right? So what you would do is take any point, right? You should apply it to all the points of the shape. So always start with the corners, like those, all right? So this one, count 3 across. So 1, 2, 3, all right? So that one's going to end up here. And same with the others. And then, of course, you want to go 4 down, all right? So 4 down. So it ends up, the final position is there, all right? And then you can either do it again with the other 2 points, 2 corners of a triangle, for example, all right? Or you can just look at the shape and just transfer that shape there. So it's a triangle that looks like that, right? For example. Is that okay?
Yeah.
Makes sense, all right? It doesn't matter whether it's a triangle, square, rectangle, whatever shape you want. All the corners have to move in exactly the same way. And you'll end up with the same shape, but in a different location, all right? So if I were to just do that, so effectively you're doing that. So that's -3, and that's -4. All right? Right. Any questions on that one? No? You're right with that. All right, fine. And then I'm going to go into reflections. Reflections. Okay. Now, in a reflection, you will have, the first thing is a mirror line. So whenever they give you a reflection to do, right, they will give you the line in which to reflect it. Okay? So we know with reflections in general, if you have a shape and you reflect it, this is your mirror line, right? That one there. And it'll be effectively the same shape, but flipped around. So if I had a triangle there, like that, and you had the mirror line, same thing, it gets flipped. The shape more or less remains the same, but it will get flipped across. All right? Size doesn't change, and the nature of the shape doesn't change. It was the same for translation. All right? You're moving it, but the size and the shape will not change, and it'll remain the same way up. Okay? All that makes sense, right? Now, it's the mirror line that usually causes a problem. All right? So there are 3 types of lines that you'll see in GCSE. Okay? First type of line is x equals a number. Do you remember what kind of line that is? No? All right. That is going to give you a vertical line. All right? I'll show that in a graph in a moment. But so if x equals a number is a line that you're given, that's going to be a vertical line. All right? Y equals any number will be a horizontal line. Okay? And finally, the other common one that they give you is y equals x. That one is if you have a standard xy graph, right? It's exactly diagonal halfway between the 2 axes, like that. All right, so it's going to go like 1, 1, right? This one's -1, -1. So where all the numbers are equal. So the next one's going to be 2, 2, and so on. Does that make sense?
Yeah.
Any questions on that?
No.
No? All right. So those are the 3 types that you are expected to know. And I'll illustrate that on an actual set of axes. Whoops. Is that going to work itself out? No, it isn't. Hope the screen doesn't slip while I'm doing that. Okay. All right. So if you have that, and that's your y-axis, that's your x-axis as always, right? And the numbers are 1, 2, 3, 4, etc. All right, and 1, 2, 3. Minus 1, 2, minus 3, minus 1, minus 2, etc. You're familiar with that, all right? If I have a line, for example, I say x equals 2, all right? Then it's, as I said before, a vertical line. X equals a number is a vertical line through the point on the x-axis with that value 2. So that's going to be here, all right? So that means that. Does that make sense? What that means for later in your GCSE is that it's a line of all the points that have an x value of 2. Obviously the y values are changing, but if I just say x equals 2 as a line, then it's a vertical line through 2 on the x-axis. If it were to be, for example, x equals minus 3, then that would be through here. Again, vertical. All right? Make sense? All right. And then let's do y equals 1. All right? So 1 on the y-axis, and you do a horizontal line through that. Okay? So that's y equals 1. And again, if I change that to y equals, for example, minus 2, then it'll be through minus 2 value on the y-axis, and again, a horizontal line. Okay? And the final one, I don't usually use black, y equals x, right? That one is going to go through these corners here, where the x and y values are the same at every point. So this is a point 1, 1, that's a point 2, 2, 3, 3, etc. And then minus 1, and so on. Okay. Let me see if I can get this through the axis properly. Oh, not bad, not bad. Okay, so that one is your y equals x. All right. So in reflections, always read the question carefully. The shape will usually be given to you, all right? But then look at what line they want you to reflect it in, all right? And the properties of a reflection are as follows. If I take a shape and I don't know, let me just take a look. So for example, this one here, like that, all right? And I say reflected in the line y equals x, all right? So first of all, I need my y equals x line, like that. And then this shape is going to be reflected in it. The important properties you must remember, all right? All the points of the shape and the shape itself, right, when it's reflected, will be the same distance from the line as it was on the original side. Okay? So usually the best way to do it is turn your screen around and then draw sort of like a dotted line, maybe like that. And you can see that that is like diagonally across. Okay, 1 square. So do the same on the other side, like that. So that gives you the first point, all right? And again, the same. So that, look at that, diagonally, 1.5, for example, like that. And this one, 1.5 again, like that, yeah? And therefore, the shape ends up like that. Okay. And if you were then to, get rid of your dotted lines, in GCSE questions, you should leave any light pencil marks there to show your workings. In other words, those are your construction marks, right? And sometimes you actually have like 1 mark is credited for showing how you got the result. All right, so like the y equals x line, and any dotted lines or whatever you've done in order to create the shape, right? So this was shape A, and it's been reflected to shape B. It's the same size, and the proportions, like the shape itself, is the same, just been flipped over. Okay? Does that make sense? All right. If I were to do one more and say we do it in, I don't know, yeah, right. X equals 1. All right. First thing you do again is draw your mirror line, and that, remember, is through number 1, yeah, on the x-axis. And you do exactly the same thing. You sort of take a point and look at how it relates to the mirror line. So 2 squares away, and go exactly 2 squares across like that. Like there. All right? And this one again, like that. That one obviously is going to be behind that, so whoops, bit of a wonky triangle, but you get the picture. All right? And that's a reflection in line x equals 1. Okay. Any questions on that particular one, the reflections? All right, cool. Let's move on then. And rotations. Here is where it gets a little more tricky, all right? Because with rotations, you need a couple of different bits of information to do a rotation. You've got to have the direction. So if you go this way, sorry, that way, then that's clockwise. Or if you go that way, then anti-clockwise. All right. Next thing you need is how far. And that usually will be how many degrees, all right? So they'll give that to you in degrees. So for example, 90 degrees. So that's like a quarter turn, all right? 180. Okay. And there's no point in doing other ones. Usually in GCSE, you'll get 90 or 180. But yeah, you could even have 270, right? Or any other angle in between. All right, but those are the most common ones, 90 or 180. If it's 180, then you don't need to worry about whether it's clockwise or anti-clockwise, because whether you go half the way around a circle that way or that way, you end up in the same place. All right, so 180 direction is not really important. But if it's anything other than 180, the direction is important. Okay, clockwise or anti-clockwise. Lastly, the thing that confuses most people is what we call the center of rotation. All right. In other words, that's the point about which you are rotating it. And this particular one is best demonstrated with an actual example. All right. Sorry about this reflection here. All right. So let's take some example. All right. And okay. So imagine I've got, again, my favorite triangle. My triangle there, right? And I want to rotate it. So that's A. I'm going to rotate it 90 degrees. Well, that's not good. Clockwise. All right. And about, the way they say it, about the origin. So in other words, 0 there, the origin. Okay? All right. Now, if you're doing it with tracing paper in your exam, all right, all you want to do is take one of your corners and connect it to the point about which you're going to rotate it. So in other words, the origin. All right. And you could use your protractor, measure out 90 degrees if it's a 90-degree one, right? And you'll find that you have to draw some sort of a line to show where the 90 degrees is. Okay, so that effectively is 90 degrees. All right. And then you go ahead and whether you're doing it with tracing paper or otherwise, you rotate it. Okay. So that point is going to rotate through 90 degrees and it's going to end up here. Can you see? Right? If I take that across, it goes there. All right. So like that. And again, this one, all right, about the same thing. If I were to do that, like that, all right. And again, you do a 90-degree thing. So that would be, I'm going to have to be careful how I do this. Please bear with me 1 second. I just want to make sure I'm doing this right. Okay. I think it goes somewhere like that, right? Or not. No, sorry. I've got to get my angles right. Okay. Let's go back and do that again. Okay. And that one's going to end up, the angle is actually going to take me through there. All right. Okay. And I'm just going to cheat a little and do that first because I'm getting the angles all weird. That is the shortcut to it all. All right. And this one and that one, etc. You can see all the different positions the corners would be in. All right. That line there, that's what I was trying to guess at the angle, but without a protractor, doing it freehand is a bit dodgy. But you get the gist of what I'm doing. All right. Now, the simplest way to do it, okay, if it's a 90-degree, right, that one there, it's literally take, you know, the corner that you're in. Okay, so let me show you what I mean. That kind of a corner, it's called a quadrant, right? 1/4 of the graph. Take that and take the relationship between the shape and the axes and then flip it. So take that whole shape and flip it across like that, 90 degrees. Does that make any sense or am I confusing you?
It makes sense.
Yeah? All right. And you could go either direction. Okay. If you were to go 180 degrees, all right, so that means you'd be in the opposite quadrant. So this is 90 clockwise, and 180, you'd end up down here, like that. All right, that's 180, about the origin. Okay? So all that line tracing and whatever, right, it's something that I personally wouldn't do. It's easier to just envisage or try and sort of guess. Guess is the wrong word, but imagine what it would look like, because you know 90 degrees is going to flip onto its side. And then it's a question of taking the same relationship from each point to the point that you're rotating it about and repeating it on the other side. Does that make any sense?
Yep.
You sure? I haven't confused you with my weird dotted lines going in the wrong direction? Okay, all right. I want to show just one more that isn't about the origin, okay? In case you get a tougher question. And I'm going to... And I'm not going to do the tracing paper stuff and whatever because I'm not very good at that. What if I had exactly the same shape? Okay, and now I'm going to do 90 degrees anti-clockwise, all right, about the point, let me pick a random point here, about 1, 1. Okay, so the point about which I'm rotating, the center of rotation, is going to be at 1, 1 there. All right, so now this one, take the vertex here, the corner that I'm pointing to there, all right, that one there, and draw a line. So I'm going to do, let's do it in red, like that. That line needs to rotate 90 degrees anti-clockwise. So you want to move that line like that. And we know 90 degrees is a right angle. So that line is going to end up going like that. Does that make sense? Yeah? All right. So therefore, on that line, we are 2 squares away from the center of rotation. You're going to do the same thing along the reflected line, the rotated line. 2 squares away. All right? And you can either then just try and imagine the shape, or you can do the same again with the other ones. All right? This one, for example, on that line, so this bottom corner, is 3 away from that. So that's going to go 3 down, isn't it? Like that. Does that make sense? Yeah? All right. Give me a guess as to which way this thing's going to go. So we know the bottom of it is there.
Yeah.
Okay. Now, is it going to go that way, or is it going to go that way?
To the right.
To the right?
Yeah.
Nah.
Oh.
Oh. Okay. You had a 50-50 chance, didn't you? Right? Okay. Remember, when I'm going to rotate this thing, all right, down like that, okay, that line obviously is going to end up flat, okay, and this thing is going to follow around. So it's going to be like this. Does that make sense?
Yep.
Yeah? You can do this all with tracing paper, right? They still allow you that in the exam and stuff. But I would honestly learn this method. With me and tracing paper and dotted lines and things, it never works. This is much simpler. However, when I give you some questions to do, or indeed you do some practice, let me know if you need more explanation on that. Okay? Once you've had a go at a few questions, it might be a little easier. All right. Any questions on this? All right. Now, the last one. And this one is not as bad as you might think. Enlargements. Enlargements, like the rotations, require 2 or 3 bits of information. All right? You need a scale factor. All right? Scale factor is how much bigger is it going to be, okay, for each length of the shape. So, for example, if I do a scale factor equals 2, it means everything's going to be twice as big. All right? So if I have a little triangle like that, 1 across or whatever, I'm going to times each of the sides by 2. That's what a scale factor means. So it's going to be twice as tall, twice as wide. Okay? And so this one is effectively times 2. So the scale factor tells you how much bigger to make each of the sides or the shape in general, the lengths of the shape. Okay? And you can then have something that I'll come on to later on, but I will do it the other way. If you go from the smaller shape to the bigger one, it's times 2. Okay? If I went from the bigger shape to the smaller one. Any idea what you times it by to get from the bigger one to the smaller one? Go on, if this one is double that one, so the small one doubled gives you the bigger one, then if you start with the bigger one, what would you have to times it by to get back to the smaller one? Half.
Yeah.
Yeah? Does that make sense?
Yeah.
Okay, times 2. And then if you had to go from a bigger to a smaller, the scale factor will be a fraction. All right? Like that. Okay, and then the other bits of information you need is scale factor, and you need what's called a point, which is a center of enlargement. Enlargement, sorry. Okay, all right. So that basically is all you need, and I'm just going to do an example rather than waffle on about it. All right. So let me take a standard example like that, and okay. So stick with our normal triangle. All right, and like that. Okay. And let's say I want to enlarge scale factor 2. Let's keep it simple. All right. And this time I'm going to do center of enlargement. Okay. Is origin. Okay. Again, around the origin here. So the easiest way to do this is as follows, right? From your center of enlargement, do a dotted line or a straight line in pencil on your graph, right? Connecting to a particular corner. It doesn't matter which one. You end up doing at least 2. All right, so watch what happens. Like that. All right? Then do another one from, again, the origin, okay? And connecting, I would say, this top corner here. So, like that. All right, okay. Next step is look at how far you've gone to that first corner here, so this one here, all right? And double that length, okay? In GCSE questions, they will usually give you sensible whole numbers, like corners or something, all right? And so I want to go, that's that, and then double that exactly. So you end up there. Okay, can you see that one there? Yeah?
Yeah.
All right. And do the same here. So look at what goes on here. So to get to this top corner, all right, you're going 1 across from the origin and 3 up. So effectively for an enlargement, you're going to go 2 across and 6 up, all right? Something along those lines, and my line's a little bent. Okay, so double it, and it turns out, oh God, let's make sure we get this right. Top one, 2 across, 6 up, over there. Okay, and so you can see my dotted lines. That's why I don't like my dotted lines, because they go all over the place. So if we know that these are those 2 corners, the diagonal corners, join them up, and then you can now picture the shape.
Yeah.
Yeah? So the point I'm trying to make is that you can either use a ruler and measure these distances and double them, or whatever the enlargement factor is, all right? Or you can count how many squares across, how many squares up, etc., and then multiply those coordinates by the scale factor, all right? And I'm going to actually put that down because that's a shortcut. Can multiply coordinates by the scale factor. That's the easy method. And that is actually the simplest, easiest way of doing enlargements. If they ask you to show your like drawing or construction or whatever, then yeah, you've got to do these lines and things. But if it's just, show the enlarged triangle or whatever it is, then you simply multiply, take each of the coordinates. And I'm going to prove that point to you, right? Just so that you have a really easy way of doing it without having to mess with directions and tracing paper and whatever. Let's take this. That point there is 2, 1, isn't it? Right? So you've got 2, 1 for that first point. Multiply both of them by a scale factor of 2. Like that. And you get 4, 2. And guess what? That one there. 4, 2. Spot on. Make sense?
Yeah.
Okay. That one here started off life as 1, 3. Oops, hang on a second. My 1, 3, again times 2. You end up with 2, 6. And that's exactly what this is. All right. And this one here was 1, 1. Oh, hang on. Do this properly. Times 2 equals 2, 2. And that's exactly there. Do you see?
Yeah.
Now, the one thing tricky about center of enlargement, or indeed the enlargement scale factor, you can have one of two things. And I'll explain that as the last bit. The scale factor can be, can be negative or indeed and or a fraction. Okay? Now, what does a negative mean? All right, it'll be the opposite side of the center of enlargement. Okay? So, if I am multiplying this, for example, by -2, okay, I'm going to end up with a shape that's somewhere down here. So this is it's going to be over here, and that one, bear with me, there, and that one. I know I'm doing it rather quickly, but I just want to give you the gist of it, and that way we can finish this quickly. So going back to this one was scale factor times 2. This one is scale factor times -2. Now, this is the important bit. If you have a minus, a negative, so it'll be opposite side. You see, this is a center of enlargement.
Yeah.
Yeah? It'll be on the opposite side. Okay. And it will be inverted, means flipped. You see how it's gone upside down? Yeah? And that's effectively what's going to happen. So, in other words, that one comes down to here. Right? So this top corner. the bottom right corner, so this one here, comes over here, right? And so on. Do you see how everything sort of crosses over? Right. And if it's a fraction, it'll get smaller. Okay? So, I don't know, if I did this, let's say, times half, and I'm going to find another color. Let's do a black one. Right? If I were to do half of this, it would, this is not so good, about there. And there, and there. That's a factor of a half. Do you see how it's half as tall, half as wide, and it's half as far to the, oh, hang on, it should be there actually. I've got to be careful what I'm drawing here. It's not easy. Okay, let's go back with that line that I had. Okay, and it'll be half, right? So that's what I meant to do. Okay, all right. Have I confused you totally, or does that make any sense?
It makes sense.
All right, just about maybe. Okay, all right. This method that I've shown you, the easy method, all right, works for origin, where center of enlargement equals origin. So if it's from the origin, just multiplying the coordinates by the scale factor will give you your enlarged shape. Okay? Even when it gets smaller, we still call it an enlargement, but the scale factor is a fraction. All right? Does that all make sense so far?
Yeah.
Okay. The method I said about the dotted lines and measuring, like distances and so on and so forth, right? That you will have to do if it's something other than the origin. Okay? And I know this is getting a bit tedious now, but that's the whole topic in one place. I'm going to give you one last example, and I'll do it very quickly. So, okay. Imagine you've got again the same triangle, and this time we're going to do a scale factor equals half, all right? And we're going to pick some weird center of enlargement. Equals, no, actually, you know what? I'm going to do, yeah, that's fine. Half from 1, 1. Okay? So my center of enlargement is this point here. So I'm going to do everything relative to this point. All right? This time, you can't just multiply the coordinates. You actually have to draw the lines. So here, try and do that. And like that. All right? So from the center of enlargement, this point here, 3 across, 1 up. So we're going to go 1.5 across and half up. All right? Does that make sense? Okay. This one here is 2 across and 3 up. So we're going to go 1 across and 1.5 up. So you can see how it's on that point there. That effectively gives you your shape. Does that make any sense?
Yeah.
Yeah. So this is half, scale factor half. From center of enlargement, 1, 1. Okay? So if it's not the origin, you're going to have to do the lines and use the technique I've just shown you. If it's the origin as a center of enlargement, then you can just go ahead and multiply the coordinates by the scale factor. All right? Any questions on any of that?
Yeah.
Okay. And again, I go back to this particular one. Sorry about the dotted lines, all right? That one, I was a bit off in my angle, all right? But I hope it made sense in the end, okay? I'll give you some questions. You can have a go at that for homework. If you're not sure, if there's any bit you need more clarification on, yeah, just drop a message or something, okay? Right, hopefully that has helped a little.